Assalamu alaikum. Myself Zakia Sultan and my thesis partner is Shoaibul Islam, and the topic is lung cancer detection and classification from CCT images using ensemble deep learning model. Here are the outlines of my whole presentation. We all know that the world's most common cancer-related death is lung cancer. People diagnosed with lung cancer are 65 or older. So, early detection is the key to improving patients' outcome. The available techniques that used for detecting lung cancer are chest X-ray, MRI scan, CT scan, PET scan, etc. But only these existing techniques introduce some problems like challenges to identify lung cancer in the early stage and avoid the scans of low quality and continuous noise and direct human participation that may cause personal use. These are the literature reviews, and after that we observe some problems and data is more dataset deserved of multiple classification, low robustness and complexity. The objectives are collection of large dataset both PACE city and chase city and balance them using deep learning model MobileNet B2 VCC19 and Bayesian, creating weighted average hard-coding, submitting ensemble models, and finally provide a comparative study. Top-down hierarchy: input dataset, pre-processing, splitting dataset into training, validation, and testing. Use transfer learning approaches, train the model, evaluation the parameters, save the result, and hyperparameter tuning. Ensemble models: the individual prediction are used to creating ensemble models and to predict the final prediction. In weighted average ensemble model, the final layer of the three transforming models are used to concatenation and put into the fully connected layer, and the final fully connected layer contains five filters to predict the five classes of cancer. And in hard voting ensemble model, the final prediction works according to the highest votes of the model, while short voting it considers the each classifies predictions probability. After averaging the predictions, the highest probability gives the final classes. And for dataset pre-processing, we use image augmentation, feature extraction, and dataset splitting. Now, after observing results, we take some decision. These are the accuracy curve and these are the loss curves. In both cases, weighted average ensemble models comparative works better than the individual transplaning models. And these from this confirmation matrix, ResNet 15 individually works well. And from this, the hard voting ensemble models predict more accurately with a low rate of false prediction and high rate of true predictions than the other ensembling model. And from this error curve analysis and the ROC curve, we get the best result in hard voting. So we proposed hard voting as the best transfer learning model according to the other two models. And these are the comparative study with respect to the other state of other model. Our project impacts on society, health, and the safety, and addressing complex engineering problem and complex engineering activities. We have some limited data set as low computational power and study only lung cancer detection. So we say that our models classify five classes of cancer accurately, and we observe three ensemble models and get the highest accuracy in hard voting ensemble models. In future, we created more robust models by extensive feature tuning process, enlarged dataset to include other types of cancers. These are the references